I started by writing out the problem on a blank piece of A4. I always found these the easiest to do work with. The first thing I noticed was how eerily similar the question was to a quadratic. Yet, I was thrown off by the numerous instances of cos in the equation. When had we learnt this? I kept my cool. Every problem has a solution. In the case of a quadratic, often two. I substituted every instance of cos to the much more friendly u. Suddenly, the equation looked like a much simpler quadratic. I remembered my learnings from the first semester. To solve quadratics, we must find two numbers that multiply to equal a times c, in this case, -2, and add to b equal b, in this case, 1. The solutions seemed obvious to me, -1 and 2. I substituted them in for the b value, as I had been taught, then performed some quick factoring. A moment later, we had the two solutions for the quadratic. I quickly solved each to isolate u. I took out a new piece of paper and started by substituting the cos values back in. I took cos x equals -1 first. This was easy. From my knowledge of the unit circle, I knew that in order to reach the x or cos coordinate of -1, a rotation of pi had to be made. This gave me my first answer. Then I looked at cos x equals 1/2. This was slightly harder. First, I had to use the unit circle to determine which value would be positive. That is, in which quadrants a potential answer could occur. I remembered the helpful acronym, all SHARs take cash, and deduced that a positive cosine answer could only occur in quadrants 1, A standing for all values are positive, or 4, C standing for only cosine values are positive. Then I turned to the special triangles. Of the two I knew, only 30, 60, 90 would get me the correct answer, as I could clearly see both a 1 and a 2. Thanks to the helpful acronym SOHCAHTOA, I knew cos involved the adjacent side of the angle over the hypotenuse. Only by viewing from a 60-degree angle could this answer be 1/2. Then I converted to radians. If 180 degrees is pi, 60 degrees must be pi divided by 3, or pi/3. However, I knew there was another solution on the other side of the x-axis, and the distance from the x-axis would also be pi/3. If 6 pi/3 was a full rotation, then 1 pi/3 fewer would have to be 5 pi/3. I now had my three answers. There was a way to quickly verify whether or not these answers were correct. I examined the frame of a cosine wave, marking pi at the halfway point and 2 pi at the end. From here I could quickly tell that at a half, I had two answers, one 1/3 of the way to pi, and the other 5/6 of the way to the second pi, verifying two of my answers. For my second value, I looked at the cos of -1. There was only one solution, occurring directly at pi. This answer was also correct. I drew a box around my three answers, enjoying this feeling of triumph.